2020, September 5th. Lightning strikes and a strong wind expands a series of fires. The Northern Complex Fire in Northern California destroyed 318,935 acres. Even though I live 260 miles away, I still remember the skies becoming burnt orange, like a scary carved pumpkin. The acrid smell gave me flashbacks to Beijing, China, where there were cigarette butts everywhere you stepped. And not only because of the smell, but because you could feel the ash in your nose as well. As a 12-year-old in California, I was terrified by the contrast between the bright blue skies and dark orange smog. It turns out that the orange skies were caused by the chemicals in the ashes being released into the air. These chemicals create a barrier that pollute air quality, but the oxygen in the ocean offsets this problem. So we got kind of lucky with this fire. However, according to a research from Yale University, oxygen levels are expected to decrease 5% in less than a century. At the same time, carbon emissions are growing exponentially because of meat production, fossil fuel use, and various other causes. This increase in CO2, decrease in oxygen, is a deadly combination. Another contributor to the carbon emissions problem is gypsum drywall. Drywall is a construction material used in the base of our walls and ceilings. It's what's underneath the paint and plaster of our living room walls. Between the burning of fossil fuels to power drywall production, the extraction of gypsum, and the installation of drywall, this material has a carbon footprint of 140.7 kilograms of CO2 per ton. Then, during a fire like the Northern Complex Fire, drywall creates an even bigger issue. When it's burned and more chemicals get released into the air. What can we do to lower carbon emissions and prevent further reductions in air quality potentially caused by house fires? Mushrooms.
Yeah.
No, not what you eat. In the soil under mushrooms exists a complex, rich network of fungal threads called mycelium, a compound that can be used in everything from meat alternatives to packaging. Imagine a wall made out of mycelium instead of the regular drywall we use. You might be wondering if you'll start growing mushrooms out of your wall, or if your house will smell like mold. And to be honest, that is also what I thought at first. Fortunately, that's not the case. I learned that mycelium was a common packaging material, so my thought process was this. If it's a great packaging material, then it must be good at keeping its shape, so it will be suitable for building walls because of its strong structure. This leads me to ask, what would have happened if our walls were made out of mycelium during the Northern Complex Fires of 2020? Well, let's not get there yet. Let's talk about construction first. To construct the mycelium wall, I obtained a mycelium material kit with hemp hurd for added strength and density. I added 4 tablespoons of flour, 3 cups of water to create a moist environment, and then left the mixture in a sunlight-free 72 to 74 degrees Fahrenheit location for 4 days. After the mycelium kit started growing, I broke up the clump of hemp hurd and mixed 2 cups of biochar to enhance mycelium growth and 2 cups of wheat straw for added strength. Additionally, I added 6 ounces of clean sand and 4 tablespoons of nutritious flour, at least to the mycelium, to boost mycelium growth. I mixed the materials in a 12 by 12 by half-inch storage tray, which I used as the wall temp. After 10 days, I removed the wall from the tray and dried it in an oven for 6 hours at 180 degrees Fahrenheit. Here's my final result.
Yay!
I conducted 3 tests to assess the mycelium wall as a proof of concept. Number 1, the sound absorption test. Number 2, the water resistance test. Number 3, the fire resistance test. Each test was ran with multiple trials to ensure certainty. The sound absorption test used the sound of a mosquito constantly buzzing from a phone to determine the sound level in decibels from the opposite side of the wall. The water resistance test used misted water to measure the remaining moisture content. The fire resistance test used a blowtorch to assess the time the wall began to burn. For comparison purposes, each test with the same conditions were done on the drywall. The preliminary outcomes were very exciting. As you can see from this graph, the mycelium wall blocked off more sound. Since the average of the mycelium wall in blue was 76.41 decibels, compared to the drywall, 77.59 decibels. You won't have to hear the screaming of kids having a pillow fight anymore. In addition, the mycelium wall and the drywall were both conducted in the water resistance test. Although there are a few areas where the moisture content remained the same, overall, the mycelium wall repelled more water than the drywall. The mycelium wall had a mean moisture content of 10.17%, while the drywall had a mean moisture of 11.54%. This difference could potentially reduce the risk of mold due to water buildup in homes. The next experiment was to see how mycelium walls could hold up under the same conditions in the northern complex fires of 2020. This graph shows that both walls burned at around the same temperature on average. However, the mycelium wall resisted the flame for a longer time. The mean resistance time for the mycelium wall was 35.94 seconds, compared to the drywall, 24.13 seconds, which is a difference of 11.81 seconds, which can mean life or death. And personally, I choose life, obviously. More of the above tests need to be run. However, this proof of concept is a positive indication that the mycelium wall may be an effective alternative to drywall. Switching to this mycelium wall has several environmental benefits. The mycelium wall itself has a carbon negative footprint, and a component of this wall, biochar, removes CO2 from the atmosphere. Looking to the future, since gypsum is a non-renewable resource and causes CO2 emissions, using mycelium in its additional substrates will be a much more abundant and sustainable option. Another future consideration when considering the mycelium wall is its cost factor. This will be addressed with large-scale production versus small batch materials. So both the labor and supply costs will reduce significantly. Regardless, if this switch lowers carbon emissions, this wall is worth it. The next step is to transfer this formula into a factory environment to scale up its production. Looking back at the Northern Complex fires of 2020, we can now answer, what would have happened if our walls were made out of mycelium? Well, since mycelium walls are more flame resistant, first responders would have had more time to prevent more houses from being burned down. And fewer chemicals would be released into the air, preventing those scary orange skies. While this solution won't completely fix air quality or house fires, the most important thing is to take action and develop sustainable solutions. Why? So that our future will be filled with bright blue skies. Thank you.